Okay, 3.5, we were looking at horizontal asymptotes, or limits at infinity. Okay, so quick kind of definition here. The line y equals L is a horizontal asymptote of the graph of f of x if one or both of two things happen. Either the limit as x approaches infinity of f of x equals L, or the limit as x approaches negative infinity of f of x equals L. And L is some number here. And again, this would be y equals that number because we are a horizontal line. If we were a vertical asymptote, then it would be x equals the number. Okay, but y equals here. Okay? So then as soon as you identify either that you are specifically being asked to find a horizontal asymptote, or you see one or both of these two things in your problem, x approaching infinity or x approaching negative infinity, then you are going to do kind of a two-step thought process. I call it the principle of dominance because the whole idea here is as you are looking at your function, you're trying to figure out who is my dominant power. Like I said, it is a two-step thought process. Step one, you would match up the highest powers in your numerator and denominator. We are looking for just the highest degree because that's the one that would be controlling my function out at infinity. I typically describe this like someone being kind of a little bit of a bully to a certain extent. Like they're the ones who are going to make everyone else do what they want to do because they are the biggest. And so same thing here with our powers. As we're looking at our function, whoever is the biggest, the most powerful, is going to force everything else to do what that highest term, that biggest term wants. And so we're concerned with the highest powers in both the numerator and the denominator. And once you've identified what those are, you're then going to compare them. Between the numerator and the denominator, you will find yourself in one of three scenarios. The first is you might identify the highest powers and see that the numerator and denominator have equal power. Well, if that's the case, the numerator is not going to trump the denominator, or vice versa, the denominator won't trump the numerator. They will work in tandem because they are of equal power, and so you would reduce their coefficients to get your horizontal asymptote, or asymptotes. In some cases you do have more than one. In other cases you might look and they are not equal. The numerator actually has a higher power. Well, if that's the case, for all intents and purposes, because the numerator has a higher power than the denominator, it's going to control it, right? It's dominating the denominator. And so the denominator has essentially zero power. The numerator has it all. We'll picture that for a second. Picture a value, some numeric value, maybe 12 on top. That's the power of my numerator. And 0 on bottom. Well, what's 12 divided by 0? Doesn't exist. That's undefined. And so if my numerator is dominating, then I have no horizontal asymptotes. Also sometimes shows up as infinity or negative infinity. And then the third possible scenario is you might look and see your denominator has the highest power. Well, if that's the case, then the denominator takes all of the power. It's the one calling the shots. It's the one controlling what the function is doing. And so, in essence, the numerator has zero power. Well, again, picture as 0 in the numerator with a whatever the power is on bottom, 12 on bottom, 0 on top divided by 12 on bottom is 0. And so you always find yourself in kind of one of these three situations. Okay, so we're going to do several examples here modeling this. Example 1, we are going to find the horizontal asymptote, or asymptotes, of f of x equals 3x squared minus 7x plus 4 all over 11 minus 5x squared. Okay, so after we walk through this one, I'm going to encourage you to pause the video on the next two, give them a shot, restart it when you're ready. That way you're getting engaged. Am I actually understanding what we're doing here? Okay? So here we go. As soon as you see horizontal asymptotes, you're thinking, okay, limit as x approaches infinity of my f of x limit as x approaches negative infinity of my f of x. And we are looking at matching up, step one here, match up the highest powers in the numerator and denominator. When my numerator, my highest power is this 3x squared, and in my denominator, the highest power is the negative 5x squared. And so those are what I am comparing here. They are the highest powers in my numerator and denominator. And once you've identified that, then you're looking at your three scenarios. What scenario do I find myself in this time? And in this case, I have a power of 2 and a power of 2, so my numerator and denominator have equal power, which means I'm going to reduce their coefficients. Well, 3 divided by negative 5 is negative 3/5. And so that's going to be one of my horizontal asymptotes. It might be my only one. The only way to figure that out is to now also check what happens at negative infinity. Okay, so we are currently sitting with negative 3/5, and it will stay negative 3/5 unless the negative, when I plug it in, will change sign. This is a little bit like our number line test. You're taking any value you would like in that negative region, negative 5, negative 10, negative 20, doesn't matter. You're taking a negative value, and you're plugging it in here to your highest terms, asking yourself, when I plug in negative, do I get a negative or a positive number? Well, if I plug a negative number, any negative number you want, into this 3x squared, we get positive times positive, which is positive. And when I plug that negative number, whatever I want, in down here, I get positive times negative, which is negative. And a positive divided by a negative is a negative, which I was already negative, and so I'm good to go. My answer is negative 3/5. If for some reason I got a sign other than the one that I already had, then I would have to change that sign, and I would then have two horizontal asymptotes, and you will see that in a bit. Okay? Okay, example 2. I'm going to change the instructions on example 2 just ever so slightly, because there are two ways you could be asked. You could be literally asked using the words horizontal asymptote, or you could be given something more like this: the limit as x approaches negative infinity of 3x squared minus 5 over 6x plus 7x cubed. And again, as soon as you see that negative infinity or infinity on your limit, you need to be thinking, oh, that's a horizontal asymptote. And now that I know it's a horizontal asymptote, I'm going to do my 2 steps detailed above here. Okay, so again, my recommendation, pause the video, give this one a shot on your own, restart it either when you are ready and you have an answer to check, or you are stuck and need a helpful hint as to what to do next. And do that on this one and example 3, the next one we're going to do. Okay, so highest powers, in this case, I'm going to match up my highest powers. I have 3x squared on top and 7x cubed on bottom. Who's dominant? Well, the denominator is dominant. It has all the power down here, right? It has a power of 3 versus the power of 2 on top. So for all intents and purposes, this top one has 0 power compared to my 7x cubed, because this guy's the dominant one. Well, 0 divided by 7 is 0. We're here in situation 3 where the denominator has the highest power, so therefore my answer is y equals 0. Okay, example 3, we have the limit as x approaches infinity of 2x cubed minus 7x squared plus 5 all over 3x squared plus 1. So again, pause the video, restart it when you're ready. Okay. So again, dominant powers, who's dominant on top? We have our 2x cubed is our highest on top, 3x squared on bottom. Who's dominating? In this case, dominating is my numerator. I apologize, it has a power of 3 versus a power of 2, so for all intents and purposes, down here my denominator has no power compared to my numerator. And 2 divided by 0 is not possible, so that would be either infinity or no horizontal asymptote. Okay. And actually, let's do one more in this vein. So if you have not yet taken me seriously, after I put this one up, do pause the video, do give it a shot on your own. That way you know exactly how you are doing with this material. If you already feel very confident, you are more than welcome to fast forward through this problem and take a look at the ones to follow. Find the horizontal asymptote or totes of f of x equals 3x plus 2x cubed over 7x minus 10x cubed. Okay, go ahead and pause the video, restart it when you're ready or are stuck and need help. Okay, so we see horizontal asymptote, so we are thinking limit as x approaches infinity and limit as x approaches negative infinity. Okay, highest power on top, we have our 2x cubed. On bottom, our negative 10x cubed. They are equal in power, so I'm going to reduce. 2 over negative 10 is negative 1/5. And then you always have to check, is it also positive 1/5? Well, let's go ahead and start with leaving as negative 1/5. And then we are going to take a negative number, any negative number you want. It does not matter. Think of a negative number. And plug it into these highest powers to see if I get a different sign, if I get positive instead of negative. Okay, well if I take a negative and plug it in up top, I get a positive times a negative, which is negative. Taking a negative and plugging it down here, I get negative times negative, which is positive. Negative divided by positive is negative, which is what I already was. And so I only have the one horizontal asymptote. Okay. Okay, next up, we are now going to do 4 of what I call kind of oddball ones. They aren't super out there, but they're, require a little bit of extra thought. Example 5, we are going to find the horizontal asymptote or totes of, and let's do f of x equals 3x squared minus 1 all over root 4x to the 4th plus 2. Okay, so I'm going to walk through this one and then I'll give you another one kind of similar to it so that after we walk through this one you can pause the video, give that next one a shot on your own. So you're going to gauge, am I actually understanding what we're doing here, or do I need to come into class prepared to ask for a little extra assistance? Okay, so again, as soon as you see horizontal asymptotes, you should be thinking limit as x approaches infinity, limit as x approaches negative infinity. Okay, dominant powers then. Up top we have our 3x squared, down bottom we have root 4x to the 4th. And so then who's my dominant power? Well, the truth is, these are actually of equal power. This is a power of 2. And yeah, I know this looks like it has a power of 4, but that's been square rooted, or it is, I should say, it is being square rooted. So this is essentially the equivalent of x squared. These are actually tied. And so if I were to reduce this, this would be 3 over root 4, or 3/2. Okay, and then we have to test our negative value. So I'm going to go ahead and start with the 3/2 I already had. But let me go ahead and take a number and I'm going to plug it in to see, does this change then to negative 3/2 when I plug it in? Okay, well if I take a negative and plug it in up top, I get a positive times a positive, which is positive. On bottom, I get a positive root 4 times a negative to the 4th, which is positive, which is also positive. So you have positive divided by a positive, everything's positive. This was already positive, and so we only have one horizontal asymptote. Okay. Okay, example 6. Find the horizontal asymptotes of f of x equals 2x cubed plus 3x. I'm sorry, I had the wrong problem. I suppose I could have made that one work, but we're going to go ahead and do this one. Root x squared plus 3 over 2x minus 1. Okay, go ahead and pause the video, give this one a shot, restart it either when you have an answer ready to check or you're stuck and need a little quick explanation. Okay, so again, as soon as you read horizontal asymptotes, you're thinking limit as x approaches infinity, limit as x approaches negative infinity of my function. Okay. So, who's my dominant power? Well, on top, my highest power is our root x squared. On bottom, we have our 2x. Who's dominating? Well, they're tied. Because again, while it looks like x squared is bigger, this is root x squared, which is essentially the equivalent of, or it's equal in power to this 2x down here. And so this is again one that's equal. We're going to reduce our coefficients. We have root 1 over 2, which is just 1/2. And then I'm looking to see, well, is it still 1/2 at negative infinity like the last one, or is this one that changes sign when I plug in my negative? Okay, so we're going to take a negative and we're going to plug it in up here. Negative squared is positive. Rooted is still positive. And then negative times 2 is negative. Positive divided by a negative is a negative. And so in this case, we actually do have two horizontal asymptotes. Because here the negative infinity actually changed the sign. Okay, two more. Example 7. Find... Actually, we've done that direction several times. Let me go ahead and give the other direction again. Because remember, they won't always use the word horizontal asymptote. They will sometimes just say the limit as x approaches infinity of 7x squared plus sine x over negative x squared equals what? And they will expect you to solve this. And to recognize that because we have x approaching infinity or x approaching negative infinity, that therefore they're asking me to find a horizontal asymptote. They're asking me to use principle of dominance. Okay, so we're going to do this one together so that then you can do the next one on your own. This is just to highlight the fact that sine of x, initially, without considering the graph, I don't actually know if sine of x is a higher power than x squared. Or I should say, I don't know if one is dominating over the other until we consider the function itself. Picture sine of x. As we work along our graph, heading out towards infinity, what is the graph of sine of x doing? Right? It's oscillating. Back and forth, back and forth, back and forth. And it oscillates between the same two values each time, 1 and negative 1. Like, that's it. Even if I squared this, it would still just oscillate between two values. Even if I multiplied it by 5 sine x, well, now it's just negative 5 to 5 instead of negative 1 to 1. But sine of x isn't actually growing. It isn't actually shrinking. It doesn't have a power, right? As opposed to the quadratics over here. We have our quadratics. Quadratics are functions kind of like this. As we work towards infinity on a quadratic, it's not just going back and forth between 1 and negative 1, kind of duping along there, like, you know, it's actually moving. It's actually growing as we go towards x equals infinity. And so in this case, when we're trying to figure out, well, which one of these two values is the higher power for my numerator, the higher power for my numerator is 7x squared, right? And then obviously denominator, there's only one term down there, so it's negative x squared. Sine of x and cosine of x, because they are oscillating functions like this, they aren't the dominant power for this kind of problem. They aren't going to be what I'm using for a problem like this to find my horizontal asymptote. because it doesn't actually grow. It doesn't actually move like the other functions do. Okay, and so then you're looking at, well, what kind of situation am I in here? These are equivalent in power, so I'm going to reduce their coefficients, which gives me -7. Okay, and then one more. This one's for you, example 8. We have the limit as x approaches -infinity of 2x cubed plus cosine 5x over 7 minus 6x cubed. Okay, go ahead and pause the video, give this one a shot, restart it when you're ready, either with an answer or you're stuck and need an explanation. Okay, so highest power, cosine of 5x is not my highest power. That's just oscillating back and forth, so here are my highest powers. So then you're asking yourself, well, what scenario am I in? Is this a numerator with a higher power, a denominator, or equal? And in this case, they are equal, so I'm going to reduce, which gives me -1/3. Now you do want to check, in this case this was -infinity, and so we do want to make sure that there's no way that for some reason this changed from the -1/3 it initially was to a +1/3. So I'm going to take this negative, any negative number you want, just like the number line, doesn't matter. Any negative number you want, and plug it into our two terms. On top, if I plug in a negative, I get a negative. On bottom, when I plug in a negative, I get a positive. A negative divided by a positive is a negative, and so I know I'm good to go. Okay, and those are horizontal asymptotes.